avoid this cross-domain callback if you are a developer, filtering at a browser level before processing information, avoid client-side validations, no security in Ajax calls, proper data structure selection based on whichever framework you are using, avoid client-side validation, secure client-side calls like eval, document write, HTML tag filtering before serving. Quickly we'll look at the JavaScript Web 2.0 based JavaScript hijacking or CSRF with Web 2.0. What we have over here is if you are streaming, for example, you are making a request, GET request and streaming, I would say JavaScript array to you. What one can do is it can make an arbitrary request using JavaScript SRC. So I'm making a cross-domain request here. Since script is through which I can make a cross-domain request because it is not abide to SOP. So once I make that request, what I'm doing over here is I'm using I know that script is actually sending me, just a minute. I know that particular script is going to send me the information which is coming from Web 2.0 application is actually array. So what I've done over here is I overloaded the function array in my browser. So as soon as I hit the entire array, I load it into this function, and then I can pass the entire information which I collected to my site, which is a get.collect.aspx data true. So over here you can see the entire information has been sent from. So I collected array information coming from your target domain, which is you already logged in. You have since I am using a script tag, it will replay the cookie. I will get the entire stream coming to me, and then I reshuffle the information coming to me to my site. So this is some of the dangers of using JSON and JS array. So what people are usually doing is if you are sending JSON, just wrap JSON to say / or some other character, so by default they cannot be loaded, and your application know that whenever JSON array comes, just remove the forward and backward trails or whatever signatures you have sent, and then consume the JSON array. So this is on Ajax. Now we'll move to web services, attacks and defense. We'll cover methodology, we'll cover footprinting and discovery, we'll cover profiling and enumeration. We'll see some of the scanning and fuzzing technique with web services. We'll see some of the attack vectors. We'll do some of the code scanning, and we'll look for the defense filtering if we get time. Here is how you can assess your web services. You have insecure web services. On left hand side you have a black box testing. You can perform footprinting and discovery. You can perform enumeration and profiling. You can do a vulnerability detection. On white box you can do code or config scanning, follow secure coding principle, follow web services firewall, and you will be pretty much secure. Footprinting and discovery objective of essentially what you have is like your page is loaded in a JavaScript which is making backend call to web services. How you identify what kind of a web service is running on your domain or a target domain which you want to assess. So discovering web services running on application domain methodologies. There are two methodologies which I usually use, crawling and spidering. These are the actually primary methods. What you are doing is actually you are hitting the site and collecting the information. Script analysis and page scrubbing, and then you can do a traffic analysis and look for a JSON calls or look for a JSON RPC calls, and whichever resource it is hitting you, it can be a JSON RPC as such. Second method is a secondary discovery. What you can do is you can search. You can go to the search engines and ask search engines that this particular domain is running with any of the web services or not. And this is a dying one which is called UDDI scanning, which is pretty much dead now because you don't have a publicly known UDDI servers. But web services has a UDDI, something called like a DNS, where you go and ask for an IP address giving the host name. Similarly, you have UDDI services by which you can query different UDDI servers. If your network is running with a private UDDI, you can query and ask for different various web services. Primary discovery, we are crawling the application and looking for .asmx. Page scrubbing, scan the page, look for path like we did in Atlas. Recording traffic and look for XML, RPC, REST and SOAP based JSON call. Page, what techniques we are using is a page scanning with grep. Then we do a simple crawling, scanning for Atlas references. where you can use a scan atlas, and finally URL grep. So let me quickly show you one or two of them. For example, over here, what I'm doing is I'm doing a footprinting and discovery on the page, say page flags. This is a completely 2.0 application where I'm doing so if you crawl this application, when you make a GET request to the front page, you will get one large JavaScript, nothing else. But when you load the page, you have several of the JavaScripts and HTML page loaded. So what I did is I copy this entire page into my local directory, and then, okay, it is copying. And then I just run on all JavaScript, I run a command looking for ASMX files. So over here I run a command where I'm looking for ASMX extension, and on the front page, which is loaded page flex, has these many web services running at the back end, like address book, WS, alert services, content proxy services, core services, and such. So it is running with several web services. If you load the live.com, for example, you will see one large web service is running at the back end with almost 120 methods on it. Crawling and spidering is pretty much easy. Fetching through Atlas we have seen, so there is nothing new here. We can go to the slides. Which one is this? Okay. Moving to secondary discovery, what you have is searching UDDI, which we have already covered, where you can search UDDI with a business services and T model. This is like a complex structures for it. Running queries against search engines like Google, MSN. You can use in URL and file type, look for ASMX. There is a tool which I have written called WS Scanner, which you can download, where it is doing, for example, footprinting. What I'm doing over here is you have to pass the Google API over here, and then you have to pass Amazon.com. For example, you are looking for web services running on Amazon.com, so it will take a permutation and combination of all different queries and look for Amazon Web Services. So over here, Amazon is running with these 5 web services on their domain. Similarly, if you go for Microsoft.com domain, Microsoft is running with 110 web services, which you can see. And on top, you can do a pattern matching where you are looking for, say, I want a web services running with something related with Amazon. So you can do a pattern matching and run the services, and you get a list of web services running with Amazon name. So this is on footprinting. Once you have footprint and discovery of a ASMX file, you can call WSDL file. It is like a interface language file, IDL file for RPC stubs. This is a web services stubs. So you have a scanning WSDL looking for methods, collecting input, output parameters, security implementation, look for binding point, map method signature, and then pretty much you can hack or you can assess your web services. Scanning strategies are manual invocation and response analysis, dynamic proxy creation. There are a lot of different tools out there by which you can create a dynamic proxy, and then you can integrate that proxy into your code. So whether, for example, WSDL.exe comes with .NET framework, which you can use, and that will create a C# or a VB code for you, so you don't have to worry about. There is an abstraction layer code. Auto auditing for various vectors, fuzzing, XML or JSON fuzzing you can do. Key part is a response analysis. Once you make a SOAP call, what you're looking for, look for a fault code or a fault string, because that is where 500 internal error and a fault code and fault string. Okay, next. Okay, we don't have much time now. Okay, over here, for example, I'm doing a web services vulnerability, so I want to do a parameter tampering. Wait a minute. Before that, I'm profiling and invoking the proxy. So for example, this is an application where I found an access point for a web services. So I go take the WSDL file. Again, a WS scanner has a feature by which you can do a vulnerability scanning. So I give WSDL file to my scanner. It will go and get the profiles over here. What you see is like entire WSDL file, and here's the profile of web services, where it is saying that it has a method called intro. Input is nothing, output is string, get product info, input is string ID, output is string, and such. So now I know like what I'm supposed to send to the SOAP and what I'm supposed to get back from the SOAP message. So over here I can go and invoke it. So I start my listener and I select one of the method over here. So I'm selecting get product info. I invoke this method and send the envelope, and I get this response. So for example, first product information which I'm getting. And then you can do a parameter tampering using the same method. You can tamper any of the SOAP parameters which is hitting. For example, I'm sending dollar in ID field here. Instead of dollar, now I say I send a single quote or a double quote here. Now it will become the traditional web hacking stuff, traditional web 1.0, where you inject various meta characters and look for response patterns. Over here you get a 500 internal error, and then you look for the stack which you are getting in information leaks. Web services auto audit, the same tool as auto audit feature, so you can select which auto audits you want to do. You select that, and the tool will run against you can even regex pattern. You can select a regex over here which you want to filter. So if you have like a fuzz load of large, then you can select regex pattern, and that will be available in red color, so you can say that these are some of the interesting points you want to analyze. And finally, the web services fuzzing is there, something called WS fuzzer, where you define a target, you define your fuzz load, you define your pattern matching load, and then you put a fuzz envelope over here. So I have these two files. For example, over here I am looking for 500 and fault code in my pattern samples, and in my fuzz load I am looking for, what is in a fuzz load? Okay, then over here I am sending hash fuzz hash. That's the where I want to make all injection of my fuzzing load, and I just click go, and the fuzz will start. It will make a lot of requests depending on what you have selected, and you can see the red where your regex patterns are matching. It will come in red, and then you can identify vulnerabilities into it. Cross-site scripting is possible through web services. XSS is possible through web services. It would DOM-based XSS via eval, JSON RPC based through DOM source of stream coming, and if it is coming from untrusted source, it may cause XSS. Injection flaws, you can make various different injections like SQL, XPath into your SOAP envelope or a JSON RPC that will go and hit your vulnerable code. Malicious file execution is also possible. You can append command with a pipe or whatever. This is the way. Everything is a traditional components or traditional test you used to make. You can make those tests through your SOAP envelope. Insecure direct object referencing is also possible, where you inject .. / and try to see what you are getting back. Cross-site request forgery, this is interesting because to do a cross-site request forgery on XML stream, what you have to do is you have to generate XML stream from your browser. So for example, if you have an X form, you can generate through X form, you can generate XML stream, or there is a trick by which you can also generate a XML stream, which I will show in few seconds. Okay, then let me move to demos. Here is a XSS with JSON RPC. Say for example, you have a show messages 1, 2, 3. When you click this, it will going to grab JSON stream. It will do a eval on it over here, and then it will do a document.write call. And this is a JSON stream which is constructed and sending to the server. So you make a first click, you will get the hello, and so on. This is a call which is sending to the server. This is actually coming as a post, and this is a response coming. And then when you click the third message, you get the error. This is actually a JSON RPC implemented in .NET. This is what you have sent, and this is what you got. So pretty much it is XSS through JSON. Similarly, if you go for, say for example, over here I have a XPath injection. So in XPath injection, you select get security token. If you send right credentials, say Sriraj as a username and password, you get a security token, this guy. But then you can bypass with XPath bypass with OR 1 = 1 OR. So you craft a XPath bypass character string and send it across, and you become a first user of the XML node. Next is Malicious is fine. File access call is possible. Cross-write request forgery.